written the matrix here again. This is a transition matrix from state to state. And part 3 is explain what it means for a Markov chain to have a limiting distribution. Outline the properties that a Markov chain must satisfy to have a limiting distribution. So basically saying that if we multiply matrix P by itself lots of times, eventually all these numbers in this column will be the same, all the numbers in the second column will be the same, and all the numbers in the third column will be the same. It basically means that they have reached a limiting value. Okay, a steady state, probabilistic equilibrium. So after n transitions, and n could tend to infinity. So if I wanted to explain this, a Markov chain, what it means for a Markov chain to have a limiting distribution, a Markov chain has a limiting distribution if after n transitions, n can be large and can tend to infinity, it's the transition matrix reaches a steady state. In this case, it means that no matter how many more transitions happen or how many more months go past, they still have each company has the same market share. That's what it would mean in this case, okay? After n transitions. Right. Okay, if the transition reaches steady state, for this to happen, if pi j is the limiting values, then pi times p equals pi, meaning that no matter how many, if you do another transition, it's not going to change the states because they've reached their equilibrium, and all the values of each state are between 0 and 1, like probabilities. The probability that they will have a certain market share is between 0 and 1, and the sum of all these probabilities is equal to 1. These are the conditions. Now for this to happen, you could have a stationary distribution, but because we see that our state diagram is irreducible, and also because some of these states were looping back into themselves, A to A, B to B, and C to C, aperiodic, a stationary distribution can then be considered to be a limiting distribution as well. Okay, so now that is part 3 done. Part 4, determine the limiting distribution for this particular Markov chain and what the long run market share is for each one. So what I'm going to do for this is use this here idea. So pi in this case is going to be composed of pi 1, pi 2, pi 3, don't need that. These are hopefully the limiting values multiplied by p, 0.4, 0.4, 0.2, 0.2, 0.5, 0.3, 0.3, 0.1, 0.6 still equals pi 1, pi 2, pi 3. More transitions don't actually change the states because they've reached a state of equilibrium. So we're going to multiply this here out and try to solve these as simultaneous equations. But there's one more equation that we can use, and that is pi 1 plus pi 2 plus pi 3 must equal 1. That's this condition here. Okay, so I'll multiply this out on the next page. Pi 1, pi 2, pi 3. 1.4, 0.42, 4.2, 0.2, 0.5, 0.3, 0.3, 0.1, 0.6 equals pi 1, pi 2, pi 3. So this row by this column should give me pi 1. So it's pi 1 by 0.4 plus pi 2 by 0.2 plus pi 3 by 0.3 is equal to pi 1. That row by that column equals pi 1. Now that row by the second column will give me pi 2. So pi 1 by 0.2 plus pi 2 by 0.5 plus pi 3 by 0.1 is equal to pi 2. And the third one, this row by the third column, pi 1 by 0.2 plus pi 2 by 0.3 plus pi 3 by 0.6 equals pi 3. Check then, 0.4, 0.2, 0.4, 0.2, 0.3, 0.4, oh, hold on a minute, this by this, that should be 0.4, 0.4, 0.5, 0.1, and then this by this, 0.2, 0.3, 0.6. Okay, that's it. So what you do next is you bring the pi 1 over to this side. It'll become minus pi 1, so it's 0.4 minus 1 is minus 0.6 pi 1 plus 0.2 pi 2 plus 0.3 pi 3. Bring the pi 2 over, so we have 0.4 pi 1. 0.5 minus 1 is minus 0.5 pi 2 plus 0.1 pi 3 equals 0. And now the next one, bring the pi 3 over, so it's 0.2 pi 1 plus 0.3 pi 2. 0.6 minus 1 is minus 0.4 pi 3 equals 0. If you look at them though, if you add this matrix and this matrix together, it equals this one. So we call this A and call this B. This one is just A plus B. Add them together. Yeah, except it's a different sign. Okay, minus an A plus B. Anyway, this one is now redundant, and we've got these two. So we need a third matrix because we have 3 unknowns, so then we will add pi 1 plus pi 2 plus pi 3 equals 1. And the next thing we have to do then is try to eliminate something. So I'll just eliminate pi 1. So that means if I have A minus 2B, that's 0.4 pi 1 minus 0.5 pi 2 plus 0.1 pi 3 equals 0. A minus 2B, well 2B is 0.4 pi 1 plus 0.6 pi 2 minus 0.8 pi 3. That's 2B equals 0. But if I change the sign of everything, that becomes a minus, that becomes a minus, and that becomes a plus. Add them together, they cancel out. This becomes minus 1.1 pi 2. And this is 0.8 plus 0.9 plus 0.9 pi 3 equals 0. So we could call this equation C. Right. So the next thing we have to do now is use this, or we'll actually call this equation C, call this equation D. Now we will use this equation and one of these to eliminate pi 1. So if I say C minus 5B, so C is pi 1 plus pi 2 plus pi 3 equals 1. And 5B is 5 times this, that will be 5.2, so that becomes pi 1 plus 1.5 pi 2 minus 2 pi 3 equals 0. But I'm going to change the sign, that becomes a minus, that becomes a minus, and that becomes a plus. And these will cancel out, and I have pi 2 minus 1.5 pi 2 is minus 0.5 pi 2. And pi 3 plus, that's plus 3 pi 3 equals 1. Call this equation D, E. Right? So now D and E are two equations in two unknowns, so now I can try to eliminate pi 2. Okay, so eliminate pi 2. So I'll have to multiply E by 11 and D by 5. So 11E is minus 4.5 pi 2 plus 33 pi 3 equals 11. And 5D is going to give me minus, hold on a minute, that should be 5.5, minus 5.5 pi 2 plus 4.5, 45 pi 3 equals 0, and we will change the sign. This will become a plus, and this will become a minus. So we now have, they cancel out, and 33 minus 4.5. I know it's like 28.5, but yeah, 28.5. So we have 28.5 pi 3 equals 11. 11. Right? So pi 3 equals 11 divided by 28.5. 11 divided by 28.5, okay. Divided by 28.5 equals 22 over 57. Okay, that's pi 3. Pi 3 equals 22 over 57. Okay, so now we put this back to find pi 2. So if I use this one, let me see, this one here, minus 0.5 pi 2 plus 3 pi 3 times 22 over 57 equals 1. Okay, minus 0.5 pi 2 equals 1 minus 66 over 57, and that equals 66 over 57 minus 3 over 19. Okay, that's great because we want the answer to be at least 0 or positive. So now pi 2 is equal to minus 3 over 19 divided by minus 0.5, which equals 6 over 19. Oh yes, of course, 6 over 19. The minuses cancel out, so we have pi 2 equals 6 over 19. Okay, then because pi 1 plus pi 2 plus pi 3 equals 1, then that means that pi 1 equals 1 minus pi 2, 6 over 19 minus 22 over 57, which is minus 6 over 19 minus fraction 22 over 57 equals 17 over 57. Okay, so now we have that the so we have found now this part the market share. So the market share for each company at the limiting distribution is 17 over 57 for pi 1, 6 over 19 for pi 2, and 22 over 57 for pi 3, and that is the steady state. Thank you.